5.3.28 Use Norton's theorem to find the V naught in the network. For this problem, we have dependent voltage source. When we calculate RTH, we need to find the IN and use VTH and IN to find RTH. If you take the component we want to find out, the circuit looks like this. If we calculate for VTH using this circuit, we're gonna ignore this 4K value. Why? Because we make that open circuit. So this way, later when we find the Norton I sub n, and then we're gonna have a parallel, okay, RTH, and then we can put them both components together to calculate V naught. So just don't forget we remove both of these 4 kilo ohm resistors. So what do you want to do? By looking at this circuit, 3 milliamp current source is going in here in this node and in going that way, right? So going into this node is a 3 milliamp. So let's try to get, let's say this is node A, KCL at A. We have one current source going in 3 milliamps and one leaving IX. So let's call this as a I1. Then entering I1 plus entering 3 milli equals to leaving IX. What else we want to do? The first loop can do KVL, right? Since we assign I1 there, KVL in 6 plus 6K times I sub 1 plus 2K I sub X equals to 0. And we want to find I sub X using this I sub 1 equals I sub X minus 3 milli. Put it back to this equation. Then 6K I sub 1 is I sub X minus 3 milli plus 2K I sub X equals negative 6. 6K I sub X minus 18 plus 2K I sub X equals negative 6. 2K plus 6K 8K I sub X equals negative 6 plus 18 positive 12. From here, I sub X equals 12 over 8 milliamps. That is 3 over 2 milliamps. We found I sub X. Now we can do KVL. This at KVL will give us negative top one 2KIX, 2KIX, that's the voltage, plus VTH minus 2K I sub X equals to 0. We have 2K, so negative 4K I sub X, 3 over 2 milli equals the negative VTH. From here, VTH equals milli kilo cancel out, 2 and 2, positive 6 volts.